every week I'm like, man, I need to talk to AT&T and figure out what the hell's going on. And then
Hmm.
I don't by the time it comes around. Anyway, so looks like we're live. Hey, everybody. Welcome back. We have David Lewis with us. We also have Andre in the Discord chat room.
Hello.
And hello. And looks like we are good to go. Yeah. All right. So it looks like my audio is a little low. All right. So if you haven't seen this stream before, we're doing a couple different things. All of this is about the Marble Machine, and if you're watching this and you didn't know that, then I have no idea how you found us. We are doing SolidWorks basically for the touring version of the Marble Machine X. So and we've bit off this kind of smaller project, which is the paper-operated music box that Wintergatan that Martin made a long time ago, way before he had the Marble Machine idea. It was a kind of an integral part of their band. And so we have a practice project to basically build one of those in SolidWorks as a smaller sort of thing. And then we're also, at the same time, we are looking at we're rebuilding the current Marble Machine in SolidWorks so that it's ported over. And then we're going to be eventually redesigning the entire thing in SolidWorks. So we're still kind of in this setup practice phase. We're also doing kind of a best practices phase. So that's kind of what we're up to. Did I miss anything?
No, that was pretty good.
Okay. So speaking of the paper music box, at first it was like I didn't know if I was, like if this was going to be a design experiment or if we were actually going to end up building one. But I think we're going to build one now. I just got this so I could measure it. I also wanted to.
Oh, you have one of those things. Sweet.
Yeah, I also wanted to measure the punching force. Because the deal with the music box is that we're not just recreating Martin's, we're making one that's like way better, something that we can give one to Martin, maybe he could use, and if there are people out there in the world that actually think this is interesting and might want one, then maybe it's something that we could make as merch for the channel. So anyway, the punching process is a pain in the ass. Like it is, there's a website that you can go to, which will have it's called Music Machine Junkies, and you can basically download these files and it outputs them for different types of music boxes, and then you have to like transpose it and then punch it, and it's a pain in the butt. But here's what I hopefully you can hear this. Come on. No? There we go. Are you ready? Live music? You ready?
Sweet. Looks pretty good.
So I already know what that is, even though I definitely did not know you were going to play that, but that's great. That's the Office theme song.
Yes, it is.
Mm-hmm.
Yeah. I thought it was going to be a little too on the nose if I started with a Wintergatan song. Also, the song I'm really excited to play, which is that Somafar Gel song, is super long. Like I actually had to truncate this song to fit it on, this piece of paper. But I did they sell them. Where did I put it? Anyway, they sell rolls of this paper that is like 20 meters long or something like that. I got one of those. So the idea is that we'll be able to put that piece of paper into the thing and onto the same music box, that is. and just pull it and write the music, and then switch out the playheads, and then switch out the punching head, playhead, and then go from there. So anyway, that's kind of the idea. The last week we were kind of talking about this thing. I need to mute my. I'm getting diabetes alerts from my son. Pushed to my phone. Like, yeah, somebody ate some candy. I can tell across the internet and over time.
It's a new level of oversight there.
I know. Yeah, if you didn't think I was a helicopter parent before, welcome to the future. So anyway, this is what I was working on this week with this thing, and let me make sure I have. Sorry, I need to make sure I have my windows open. So, hey, Amos is with us today. Hey, Amos. Make sure I can see.
Where is he?
He's on YouTube in the comments.
In the YouTube chat.
Cool. Hey, Amos.
So actually, it might be good that he's here, because if we have questions about the configurations sort of thing. But anyway, this is my current approach with the punching mechanism for this box. Basically, we have a stroke of 72 millimeters to be able to shuttle back and forth across the paper, and then there'd be a punch here. This one will be operated with a cam attached to a gear motor. I haven't drawn those in. I kind of had to go back and redo it. These are LM8UU bearing blocks. They are all over the place. They're used in a lot of 3D printer designs. They support a 3D printed shaft. But this core part, which is I think really the hardest thing to make. I'm gonna open that solo. Obviously can't make. Oh, it's frozen up.
In YouTube, I'm noticing that you're not seeing the same thing we're seeing here in Discord, but your screen is just jumping all around. But it isn't doing it in YouTube, which is weird.
Obviously, I have some fillets to add to the corners there, but this is going to be one piece of steel. So this is I have 1 inch thick stock that I can make this from. And basically, this is going to reach over the paper and be able to punch it from both sides. And each of these mounting squares are where the brackets go. The linear components go. And this is going to be hard to manufacture. I'm going to have to get a slitting saw to make this little narrow feature, and I'll be able to come through on both sides to make that clearance hole. But the idea is that I can make everything line up. I haven't drawn the bottom hole, but I can make everything line up by machining all of the kind of concentric bore features at the same time. So it'll automatically be coaxial. I was worried about the punch coming through and not being able to get into not being able to line up the hole in the die. So, Amos, I see your comment. We are in the E-Team meeting room. I don't know.
Oh yeah, maybe we should be in the CAD team one. I think that's usually what we have done.
Is it?
Because not everyone has access to the E-Team one, right?
Right.
I don't know.
All right. Well, if Amos doesn't have, let's just hop over there while we're doing this. So in any case, so that's kind of the idea with this thing, is I'm going to start off with a big piece of iron, and then mill it away. I have to add these same kind of relief cuts, try to make it not be 1 billion pounds. So that's the idea.
You could just have the holes going all the way through for the relief cuts if you want.
Well,
you're not live, by the way, Tim.
What's that?
You're not live in Discord, Tim.
Oh, sorry. Share my screen. So yeah, so that the idea. This thing in cross section, I want it to be like an I-beam, basically, right? Have that kind of thing. I want to remove the remove that kind of profile, but I do want the web in between. I don't want to cut all the way through. I want to leave that middle beam, but kind of lighten it up a little bit. The fun thing here on the punch, and I wanted to do something simple, and keeping this project simple in general is a good idea. But as I started working on it, I realized I had to do something a lot different. So the way this is going to work is that this part here is, the paper needs to be like the punching mechanisms actually, and here's one right here, right? If you look at this thing, there's a metal piece underneath it, right? And that holds the paper still flat against the hole as it punches through. Because otherwise the paper wants to come up and get dragged into the hole. You need to hold the paper flat and then punch through. And I know that, when I've seen a lot of people making dies for cutting labels back when I was in the wine business, etc., they always had these basically like razor blades that were embedded in neoprene, and the neoprene would push the things off of the die. So the way this is going to work is that there's going to be a spring in this cavity right here, which will allow this whole piece to move up a little bit, and it also is what pushes this ram of the button down. So the paper will come in here, it'll be held against this thing by a little bit of spring pressure, and if there needs to be some compliance there, it can float up and down. And then this punch, this is going to be a hardened punch from McMaster-Carr. This is for an ejector pin for a die or mold. I'm going to have to cut it down a little bit, and then this will be brass. So this guy will bear against this surface. This guy will bear against that surface. The punch will be basically brazed into this, or just soldered in, and then I'm going to be able to get everything to line up by making it all in one operation on the CNC. So
you need like a hole on the bottom as well, so that the punch can go all the way through.
Yeah, I haven't drawn.
Okay.
Yeah. The math here is that I want basically a 7mm stroke, because it needs to be able to clear, and this punch needs to be able to push the paper all the way out the backside. Otherwise, you're gonna have a plug of paper in that channel. But anyway, so that's the punch head. That's kind of what I've been working on this week, and it'll slide back and forth. I just got this thing, so I need to measure the punching force. I need to figure out are the metal gearboxes going to be, like the Flolu has these metal gear motors that have a lot of torque and move relatively slow. But I have to actually measure the force that it takes to punch the paper, and then work it backwards to actually see it.
Tim, looking at your feature tree, I don't see a shell feature. How did you get those cutouts?
I drew them and then cut them.
Yeah.
So
there's a like a one-step feature called shell that can.
Yeah, but I wanted to leave ribs in certain places. So I'm fully aware of the shell feature, but things like I wanted to leave it here, and if you shell this thing, I can show you actually before that. You get some geometry that is hard to make and that I don't actually want. Get 6mm. Right, you start getting around this thing. I know you can offset the depth of it on one side, and you can do some other customizations. It's just not exactly what I was looking for.
Got it.
I'm actually going to go ahead and on each of these sides, on the side that doesn't have the motor mount, the linear bearing, I'm going to take out these webs. Anyway, this isn't, in terms of CAD best practices, this is still on the experimental side. So, I'm designing it as I'm drawing it. I'm not being incredibly deliberate about CAD, which is okay. It's okay.
Hey, we got new people in the chat room too.
Oh yeah.
Lund is here.
Lund's here.
Happy to see him. I don't know the other guys.
So
except for Amos.
So Amos is a very swell idea, and he actually works for Avar SolidWorks in Florida.
Yep.
He's Florida man.
I don't know
a Florida man.
Debutus or Martin Sepp 42. I don't know those guys.
It's okay. So anyway, that's kind of where we're at with this, and then I don't think I've done putting. I don't know if I have. No, actually, I know I haven't. I haven't put this into the larger Marble Machine CAD. So not the Marble Machine, the Music Box CAD. So this is what I have thus far.
I've had a little bit of experience working with these pillow blocks, and I feel like it's pretty hard to like line them up. I don't know if you have any specific solutions to that.
Yeah, you just have to like not well, already as it is, the pillow blocks that I'm using, they're threaded on the side that is going to be actually a clearance hole. So in this model, these threads are going to be tapped. So I actually have to drill through from the backside. So I'm just going to make those holes a little oversized, and then basically put it together and tighten it up once it's all together.
Mm-hmm.
The Martin had mentioned IGIS bearings during I think last Wednesday's meeting, and thought that they were a small company. I'm using their stuff for the robot that I showed you, Andre. I can't talk about on the stream publicly, but because we might file some patents. But even those guys, I showed the guys from IGIS because I kind of wanted to get a design review, saying, "Hey, this is my first commercial project using your products. Can you give me some pointers?" And one of the pointers was they have 2 mounting holes on all of their linear bearings, and they're like, "We never use more than one because it's already hard enough to fit together." So you have all these linear bearings, these little linear pillow blocks, and they only use 1 hole each.
Yeah, that makes sense.
Yeah. Anyway, I guess.
What about like the flange face distance? To the bearing center itself. I mean, I can only imagine that manufacturing variations are gonna make that difficult without shims. But again, I don't really use these things, so I don't know.
Yeah.
In the real world, if there is a difference.
Right. The weird thing. So with this guy, let me see. Music box assembly. Hold on a second. I'm trying to find the paper. I'm trying to open up a new one. The pillow block grabs the shaft with very high tolerance. So the flatness, I can make sure I can make this part pretty flat. So I don't need, if there's 2 different bearings here, I don't need this kind of compliance. I just need this kind of compliance along the face of this part. So I think just by slightly over drilling the mounting holes, we'll be okay. So I'm loading in something. It's interesting. Oh, there we go. So this was my previous version of this part, which was basically to use a solenoid and to pull basically a ram. I didn't like the mounting plate on this, but basically pull this ram. This solenoid is the beefiest one I can find in McMaster car. It has a 1-inch stroke, and I'm turning that into 7 millimeters of punching distance by using this linear slide cam. So this would be a block of Delrin, a couple of pieces of bronze, and then this thing would go through. This design doesn't have the ejector button on the bottom, which is not as good. Plus, I would have to make a hole here and a hole here, and everything would have to line up. And I like the idea of machining all of the parts that have to be concentric in one setup on the CNC. I just think that's going to be easier. So,
yeah, I don't know if it's easier necessarily. It actually could be more complicated in the end. But because now you're thinking about going and buying a slitting saw and things. I mean, it'll probably work out in the end. But
when you're doing things, and especially when you're prototyping them, right? You don't want to go for perfection, and you don't want to do, you want to kind of stay within what you can do. I showed the same design I was showing to Andre. Actually, I was showing it to somebody, and they're like, "That's overkill for for a prototype." Thing is that for me, like, this is, I can show you this. This is for that same machine, right? This is a motor mount. So I have a ClearPath servo that mounts here. I have a drive coupler, a servo drive coupler that goes in this pocket, and then there's a shaft that goes through this axis to a drive pulley in the middle, and it's driving a belt. This is, I have to machine every single side of this thing, right? And for a prototype, like, normally you'd say you don't do that, but the thing is, this isn't a problem for me. I know how to do this. This isn't a technology risk. And that's generally the main thing, right? When you're doing these things, is that you want to avoid unnecessary technology risk. And so for me, the new technology with this product is I have these new servos I want to play with. They can move super fast. They actually will. You can just tell them, like, hey, go, and they'll just try to move as fast as they can before they start seeing the expected position versus the real position, and the lag between those two. And so I didn't want to make something that's mechanically not totally bomb-ass rigid, right? I wanted to make something that's insanely rigid. So, yes, I have, from this angle, I have 3 different size bores, and there's a ball bearing, and there's a bearing that goes down in the middle of that. Same thing on the other side. It's not the easiest. It's not a simple part, but anyway, it's a part I can do. So I'm not afraid of that. You know what I mean? So, like, gas slitting saw, I've never done that, but I'm confident I can figure that out. It's not a reach. That's like bragging.
No, it's just there are a couple of things to know about slitting saws, and like the finishes they leave behind and things that might end up being another a compounding of things to work out. It might not be just about might not just be about getting the saw. It's also finishing the corners and
Yep.
You won't have access to those 2 faces after you cut them. So
right.
The other thing is spring back. Once you slit that, all of the the relief that you get out of those 2 massive pieces of steel separating, you might not end up with those holes aligned anymore. That's
right. Because
probably close enough, but still.
Right. Well, this is going to be hot rolled steel. I mean, at least the stock they already have is, right. So, you ever see a YouTube channel called Edge Precision? This guy is basically like a guy, and it's a little bit like A-Bomb 79 too, where it's like the takeaway from that channel is that machining is all about setting up, basically.
Yeah.
And then measuring stuff, saying, I'm going to take this cut and I'm going to see what happened, and then doing. But he was making like a T-shaped drive shaft out of a 2,000 pound piece of metal, and he showed how after he had taken off a lot of the things, there was actually out of once he took it out of the live center, there was deflection because there were stresses in the metal, and once he relieved a huge amount of the material on the side, it actually moved. So I think what I might actually do is to make this slit and not relieve underneath here. If you see that this is a square piece, but make this slit and make it so that these parts can flex away from each other a little bit before I do, because this is going to be in the same operation, right? The slitting saw, I can run it all the way through here. That way, if it does want to separate, I do that. If I do that before I do these holes, then I think there's a better chance of them being concentrical. I've given that chance for that movement to happen once you kind of separate the 2 halves. Do that up front. Yeah, that's the idea. Anyway. So yeah, that's kind of it on the music box front. I mean, there's drive rollers haven't changed. I worked on this configuration with these slides, but I've abandoned this, and so I still have to source a gearbox. I still have to measure the force required to operate the punch, so that we can look at the torque of the motor and make sure it's going to have enough to get through there. And I probably want a safety factor of 3 for for that. So
Hey, Tim, if you don't mind pausing a second, Raphael, would you mind muting your microphone in Discord?
Oh yes, I'm so sorry.
No, it's okay. Thanks. No, it's cool.
Yeah. So yeah, that's kind of where we're at. I have some engineering to do, but I like the idea of using a cam. The other thing is, I've shown that the cam can be operated from this side. That was assuming that I would have a motor mount kind of attached to this plane back here, and then the motor would be sticking out 90 degrees. But if I can figure out how to do it, I might be able to have there's no reason that this button relationship that between this cam and this button have to be on this plane. It could be 90 degrees. It could be.
Yeah. So this is the kind of thing actually that you can test in the layout sketch, in SolidWorks if you set it up right. That kind of cam following motion.
Mm-hmm.
It's really good for that.
Yeah, I just are there cam tools?
Oh, there sure are.
Really? Yeah, because I just made one that looked right. You can tell it's not Sketch Tools. Do we have this? Is it in Sketch Tools? Where are the cam tools?
It's actually not. If you go in the SolidWorks add-ins tab, there should be a cam feature in there, I believe. I wonder if it's just not in SolidWorks connected, or at least it has to be enabled. Let me look in mine, because I'm pretty sure I have that feature.
It's kind of an ADD tangent anyway, but yeah, if you can pull it up quickly, then why not? But yeah, I just did one that I kind of said the distance between this this inner circle and the outer circle is 7 millimeters. Let me get out of. The only thing, by the way, that Fusion does that that SolidWorks doesn't, as far as I've seen, is that SolidWorks will kick you out of your sketch when you change units. Anyway.
Well, just out of curiosity, what's the point of changing units?
Just because if my brain can't get around like how big is this, I like to design in metric, right? But I live in an imperial world, so if I say,
I always turn on dual units.
Are they all?
Yeah, there's that too.
You just turn it on so that all of your units are dual?
Yes, every dimension shows both the inch and the metric, and it's very helpful.
Oh.
Yeah,
is that up in
then you can live in both worlds.
Yep. Yeah. So that's one way of doing it, is absolutely just like that. You're right, Amos. The other way, though, is when you enter a value, you can put, instead of putting, geez, how many millimeters are there in inches, and then saying 25.4, okay, 25.4, you can actually enter 1 inch, and it will just populate it.
Oh, I do that all the time.
Whatever the metric
all
is.
The time.
Yeah.
Yeah. But I mean, sometimes especially when I'm looking at this, right? And now I'm tabbing between SolidWorks and a supplier page where they're in inches, right? I will toggle my SolidWorks into inches so that I can see if this is compatible, right?
Yeah. Okay. But I actually really think Amos's suggestion is probably the most.
Where is that? Do you know? Just is that in system options?
It should be in options. If you go in the tools, and then you go to the bottom, it's options, and then there should be your screen with blurry, so it's kind of hard to see what you're doing.
You can't see you can't. I'm sharing that window, so you can't see it. Anyway, I will do that. That's a good tip. I'm not going to try to figure it out on the screen. Cool. So so we'll play with the cam, and I think I'm going to have to do a measurement of the force required for the punch, and then we will do a calculation basically based on the torque and kind of the radius of the length of the lever arm for these cams to figure out if we're going to have enough torque to get it. Should be fun. So let's.
Sounds good.
Yeah. So David, what do you got for me?
Just a small question.
Yeah.
I mean, the whole point of this punch is to make it fully automated, right?
Yep.
So you can just put in a profile, this is the song I want, and it will just make it for you,
Yep.
right?
Yep.
Yeah. Good. I missed the beginning, so.
Oh, look, when I switched to my units in that thing, look, it totally messed up my whole thing. That's gross. All right, I'm going to save that without closing. Discard. Let's see. All right.
Yeah, what? That's so weird.
Yeah, I don't know what happened there, but I was able to leave it without saving, so hopefully that will be fine. So David, are you still streaming on Discord?
I am. Yep.
So let's get you up here. Yeah. They're on the other side of the. Yeah. All right. 220. We have a company that does in my complex that does cosmetics. Never met. Anyway, whoops, that's the wrong one. How many David Lewis's can you handle?
What kind of data format will it be like to design the songs?
Good question. So Sebastian has one that goes MIDI to DXF, and then I have to resize the window here for David's layout. Wait a minute, is that your layout or is that my layout? That's David's layout. Oh no, David's watching me. David, can you share your own screen? There we go. Yeah, so there is. I'm gonna need help, for sure on the programming side. So Sebastian made one that was MIDI to DXF, but then we're still gonna have to, figure out from DXF how do we turn that into G code, basically. And
do you want me to make this less of a widescreen? Would that help at all?
It's okay. I just got to size it up to what you got. Good.
Okay.
Yeah, we're there. So yeah, there was something about like bubble. I forget what it was. I'm gonna search for it. Let me see if I can find it. There's a guy who did it. There's a Korean guy who made one. Music. Sorry, box. Korea music box. Puncher paper. I'm sure that'll find it. Google is amazing. No, that wasn't that good. Automatic music box paper, and Hackaday had it on there, and there's a few different things. This is it right here. Let me do. Hold on a second. Need to figure out how I'm going to share this. And while we're at it, you can watch David load the crank handle. Let me see. I'm going to duplicate my here. Nope, that's not it. There we go. So this is great. Well done, Tim. This is called Fun with OBS, featuring Tim Keller and David Lewis. It's comedic relief.
Oh, geez, what are you doing over there?
I know, it's horrible. I tried to.
Wow.
Okay, sorry. Oh, look! I also messed up the my reference one too. So that's amazing too.
Back to that dual unit display thing.
Yes.
It is a document setting, so you have to set it up in your template so that all the files that you make have that setting.
Okay.
in advance. You can turn it on for any document that you have open, and save it with the document, and it'll be saved going forward. But it is, yeah, if you go to the document settings and you just click on dimensions, the very top, not a specific dimension, but the first one where it just says dimensions, and then right there is a dual unit. Right under the font button, there's a dual unit display checkbox.
Boom. Are show units for dual display? No, it must be.
Yeah, that's
but
the
which one is it? Dual dimensions display or show units for dual display?
It's the dual dimension display.
Yeah, that's what I thought.
And if you check show units, it actually shows the word IN and MM or CM or whatever. So it shows the unit itself. But if you just check dual dimension display, it puts one of them in brackets and the other one just normal.
Yeah.
And so
actually, that's not a bad idea to do for many things, actually.
Yes, that's, like I said, I normally turn that on in my template because it comes in handy in so many areas and it doesn't hurt anything to have it on.
Yeah. I also generally, even though this is not it's outside of the ISO standard, but I prefer, because of using dual units, or at least understanding what the equivalents are, to make it so that the millimeters displays as 3 decimal places for a number of reasons. It helps to know if it's like an infinite decimal place or not. If it looks like because SolidWorks will they'll estimate the number, or what do you call it? They'll
round.
If it's
round.
Thank you. That's the word I'm thinking of. It will round, and so it's much better to know if it's in 3 digits for a lot of reasons. But again, also, if you're a machinist, you know that in the metric system, all code for the metric system are generally, unless it's a special feature with 4 decimal places, uses 3 to the micron. So, I mean, you might as well just design in the same units that you dimension in.
Yes.
So that's generally what I do. Or, sorry, design in the same that I machine in. So, anyway, what you're seeing on the screen now is actually the Marble Machine file itself. This is going to be the end product. And I actually just moved this to its own collaborative workspace. This is now in, I think it's Marble Machine Studio collaborative folder. And that's all it's going to live there. It's just this guy, so that my other one, the working one, doesn't get all cluttered up. But anyway, I just opened it to show you that essentially the way this is set up now, it's fully defined. As the assembly grows, there'll be more and more stuff added, and this thing will be huge. But I wanted to show how mates work when you're building it, but you want to test motion. And so I've actually fully defined this particular subassembly so that it doesn't move. But all I have to do is suppress this one particular one, and then now I can test to see if it turn. Well, sorry, that was the handle. I didn't need to do the handle. That was the handle. What did I do? The heck? Okay, I don't know what the hell just happened, because I definitely.
Because you're giving a live demo.
Yeah, it's exactly what it is. Because you can see the handle to that is the one that I am suppressing now. And yeah, so that worked. And then if I suppress the whole crankshaft, suppress the whole crankshaft, now it should be, and it's not. Okay, I give up. Anyway, that was just for fun to show anyway. I'm going to close this guy, and we're going to talk today about the rhythm machine, which is actually here. And okay, so the topic.
A little bit of background here. So David sent me a message saying, "Are you ready for configurations?" And I was like, please, because I know they exist. I know they make a lot of things easier. I actually personally want to use them if I can, but I have never ever. So if you hear me asking a bunch of dumb questions, it's because I have zero experience with configurations, and I'm eager to learn. Sorry,
Okay,
yep.
so no, that's fine. So the rhythm beaters that I designed originally, I recreated in SolidWorks. I did it as a part, and
based on the
if you know
detail file that Andre did.
right, so if you know anything about, actually, where is this? Oh, did I delete this already? I might have deleted it already. Hold on a minute. That's what? Did somebody? Oh, all right. This is weird.
It's been corrupted. It's now educational.
Yeah. Well, it's not. Not only is it educational, it doesn't exist anymore. I don't know what the hell's going on with that.
I don't think I touched that, but everything I touch will get corrupted to educational for sure.
Well, I guess it doesn't matter. I was just going to open the original one that I designed as a part. Here it is. This is it right here. I don't know what happened with that. Okay. And any day now. What is it doing?
Yeah, you got to be patient with connected for sure.
Just totally random thing. I just tried to update my 3D Experience to the latest version, and it was like install failed, and now I can't do anything. That's great.
Okay, so yeah, and this is the mystery one. Some files could not be opened. It happens almost every time I try to open something, but not all the time, which is weird. But okay, so when I sent him this message, I had already created. This is virtually identical to the part that I guess Andre made. Did you make this, Andre, in Fusion?
I redrew it, yeah.
Okay, so I did the same thing in SolidWorks.
Sweet.
And then I realized something. It got super weird when I realized that the drumstick tips needed to be different lengths. And I had designed it and then patterned a bunch of stuff. Mm-hmm. And then I put all the holes in. And then I realized, actually, I should have made this as an assembly. Because for a whole bunch of reasons, this qualifies as an assembly. There are configurations of various parts. The other part was that I wanted to make these springs actually a McMaster-Carr part, and which I successfully did. And also, in addition to that, the holdback screws are a commercial part. They're a McMaster-Carr, or in this case, they'll be a McMaster-Carr part, and with a hole in it. And sure. I realized this needs to be an assembly. So I sent Tim that message he talked about. So now I said, screw it.
What is not to beat you, but why would you think it wouldn't be an assembly?
Well, so it wasn't Fusion, I guess.
Great question.
Okay. So the thing is, SolidWorks has a feature. At least SolidWorks Premium does. Unfortunately, SolidWorks Connected does not, and this is really the main reason that I decided in the end to make it an assembly. But it has a feature called Save Bodies, and you design everything as a part. The whole design experience is with it as a part, and then you take the bodies within that part, and then you save them as components, and then you can automatically just create an assembly based on those components. So you're designing everything in place. You click a bunch of buttons, and then in the end, you have an assembly. And that's a feature of SolidWorks Premium, not of SolidWorks Connected, unfortunately. So I couldn't do that. The other thing is, I've been pretty vocal about the concept of creating parts when it doesn't necessarily make sense to make it an assembly, right? And I think that's kind of what Amos is sort of curious to hear about my take on, because in Fusion, if you've noticed, one of the absolute first things you learn if you learned Fusion on the internet, like probably everybody does, is rule number 1, which is create a part first, right? The first thing you do is create a component, and what that presupposes that what you have in front of you is an assembly. And it might not be. I mean, what if you're making a like a bookshelf, right, with 4 shelves and a maybe a couple side boards and a few other parts. There's really no functional reason that it has to be an assembly. There's nothing about it that requires joints, and pretty much it's kind of a bad idea, in my opinion, to turn something like that into an assembly.
Well, especially
because
if you're
now
doing something quick and you're still designing things. I mean, I like that about Fusion.
Right.
You just
Right.
you don't overthink it. You just kind of think through the geometry and you just kind of go along your merry way.
Yeah, exactly. And with SolidWorks, at least until recently, SolidWorks Connected has removed this. You had something called save bodies, and where you create it in a part. So you're in the part environment while you're designing what you're designing, and then it's not a problem that when you're done, you end up with an assembly, if that's what like you need to have in order to do to fulfill the the object of your design goals, right? So unfortunately, that's missing from SolidWorks Connected, and probably we'll see. Maybe that's just a doomed feature in the long run. But even Fusion has this feature. You can convert bodies to components, and I had a very long conversation with Will about this very early on in the current Fusion project. This is well over a year ago at this point, and he was a proponent of rule number 1, and he thinks, well, if all of your design information is all in the part, that's a better thing. And in some cases that actually does make sense if you're designing things that are used in other designs. Like, let's say, for example, you're designing a screw, and that screw is going to be used in 100 different things, and you want to be able to make new configurations of it by changing its length or whatever. All of that design information probably should live with that thing. And for that reason, it should be, I mean, in this case, a screw is not going to be an assembly. But, however, you'd be surprised to find out how many people will make a screw in assembly, because guess what? Their first thing they do when they start their design is to insert a new component, right? And so you end up with every single thing that you make as an assembly, including single bodies. And I just think that, it's just not good advice. You should be more judicious about choosing those things.
In the SolidWorks context, where we're having nested assemblies and having parts and being able to navigate in between them is so much easier. Why would you not like? I thought one of the benefits of going to SolidWorks was the fact that we wouldn't be using a workflow where you're making a bunch of bodies and then making it's kind of like you just make an assembly and you insert as many parts as you need.
So the thing is, like, the philosophy is really the same across both platforms. It's if you feel like your design is so complex that it requires motion, it requires configurations of joints between 2 different parts. If you're buying stuff and putting it in the machine that you have access to their CAD files to, it makes sense to have an assembly. But I think for the most part, like, for example, a bicycle frame, if you want to go in my world, a bicycle frame, is 9 tubes, and each tube is either a straight extrude or maybe a revolve of a butted tube.
Right.
Like, in configurations, you can make that one part easily, and there's really no need to make that an assembly, for a number of reasons. But first of all, the complexity of, in my case, I wasn't designing the bicycle, I was designing the manufacturing tools to make the bicycle. So all I really needed was the geometry from what the bicycle frame is, to be able to design the tool itself that will accommodate that geometry. And so, maybe I'll make an assembly, but that bicycle is just going to be a part.
Right. I see what you're saying. I mean, because also then, like, with in weldments, right? Really, a weldment feature in SolidWorks is a part, and it knows that you're going to be cutting this out of of steel tube stock or whatever you've done, and then you're going to welding it together, but it handles it like a part. Right? I get that.
That's a perfect example. Weldment, like it's, in fact, that weldment is a good example of where you can do a save bodies feature and turn it into an assembly if you want. But the creation of that frame happens during a part feature, not an assembly feature. Right. So, it's not a hill I'm willing to die on. It used to be, but at the same time, I don't see people working with assemblies for a particularly what's the term I'm trying to think of, for a strong reason. It just seems like a knee-jerk reaction because that's what they heard about on YouTube, right? But again, there are reasons not to, and there are reasons for it, and it's just, I don't know.
I understand.
Well, I don't want to get too deep philosophically about this, but
that's okay. But let's go ahead and dive into your configuration thing if you can pull it up. We've been staring at a blank SolidWorks screen.
Yeah, exactly. That's what I'm trying to get at. So I believe I have thought I deleted this, but I guess it's still around. Okay, so it's still here. Okay, so okay, that's why. So this was my first iteration of the Rhythm Beaters assembly, and it includes the original part file Rhythm Beaters, which we're getting rid of, and the Rhythm Beaters mounting plate, which I designed as a part. And I decided to make this an assembly because Martin designed this so it could be rotated to be timed properly. I'm not exactly 100% certain if he followed through with using that feature, but I noticed in the new video, or new, it's like a year old, it's probably even older than that, that this was definitely designed to be rotated in timing. So I actually included 4 holes because it's obviously his intention. I don't know that if he's replaced this with one with 4 holes or not.
Yeah, I was going to say, I think there's only 3 or something when I was looking.
Well, yeah, but the mounting plate that he made for the new this Beaters assembly has 4 slots. Right. There's definitely 4 slots in the back. So I don't know because he doesn't show it in the video, but I assume that this has been replaced by one with 4 holes. I don't know, but it's also, by the way, very easy to change. So, I could just say, nope, it's 3, there's 4, or there's no.
You're bringing up one.
Yeah, I think we talked to him about this on a couple meetings ago. And Martin mentioned that he had initially intended for this to be the way that you adjust the timing, but then you got the timing clutch, and so now the timing clutch is basically doing the job that this would do.
Yeah,
it doesn't use this.
Okay, yeah, and I assumed that was exactly. So again, yeah, I'm not sure what to do about that. I looking at this, I hate to put 3 holes in this other part and then have it not line up. But on the other end, it's also how the thing exists in the real world. So
yeah, we got to be super careful about that. And I think I was mentioning that, and I've actually talked with both Maureen and Andre about this, which is that for this first model we need to make sure that we're not slipping in our new ideas into this first model.
That's the Fusion model.
Huh?
You're talking about the Fusion model.
What we're doing in SolidWorks now, right? For this kind of baseline of the porting, we need to just be translating the Fusion model and not fixing.
See, I thought we were just going to do the new MMXT in SolidWorks.
No,
and the other one in Fusion.
Well, we are leaving the one in Fusion, but we're doing the MMX Studio as a design exercise, first of all, but second,
okay. I was not on board with that.
As a place to start from when we do the touring.
Yeah.
Because unless we do this, first of all, we're just going to sit on our butts for forever waiting for you guys to be done in Fusion. But the second thing is, we have to have a thing to start from. So when there's an A/B design review kind of proposal for a new whatever, you take the part that exists now and you say, okay, well, this is what we got now. what do you think of this new thing? And without a SolidWorks equivalent, it's kind of hard to make those decisions in the SolidWorks space.
I also think, some of the hesitancy that Martin has about SolidWorks is the fact that we have so much in terms of existing design and Fusion, and so there's kind of a platform. What do you call it? It's a sunk cost bias, right?
Yeah.
So if we can, while we're waiting for the studio machine to be finished, if we can be bringing the thing over into SolidWorks because we enjoy working in SolidWorks and it's good practice for us. I mean, I learned SolidWorks 2011. There's a lot of new stuff I've been anyway, so don't mind doing it. So, if we can have the existing Marble machine in SolidWorks, then, all the better. For that sort of purpose too, right? So that, Martin can feel more confident moving on to the SolidWorks platform, knowing that all the existing stuff is there. But that presupposes, though, that we need to not be changing, not even though all we want to do is fix these designs, we have to hold back in that first phase and not, make 4 holes. Not to pick on you, but we need to not do stuff like that.
Yeah, so it's also, by the way, super simple to just change it from 3 to 4. When it's a hole and it's a pattern, you just change it. Okay, so I'm going to open some parts here. This is going to be one of them. I had it open a second ago anyway. Okay, so this is one of the parts. And so now, if you see, I've got 2 windows open in SolidWorks. This doesn't necessarily work very well if you have 2 instances of SolidWorks open. For those of you who've ever tried that, you can run SolidWorks as if it's 2 computers or 2 separate instances of the software side by side. But in this case, I've just got 2 parts open within one. And this assembly process works a lot better if you do. So we're going to start off, or actually, Tim, I was going to create the assembly and then talk about configurations. Do you want to just talk about configurations alone?
Please.
Without building the assembly?
Whatever's easiest for you.
Well, it's not for me. It's just I get long-winded, and I'll be here. Let's do that. So, okay, I'm going to open the disk because that talks about it. Okay.
Can you make a 3-hole and a 4-hole configuration of that disk?
Yeah, that's what I'm doing.
Oh, that's good.
Okay, so this is the Rhythm Beater disk in its default configuration. Right now I only have one, and it's the default configuration because it's the first instance of this disk that's in the machine itself. So I decided to make it to 3. I haven't added I've already added and deleted configurations to this for this demonstration. But the idea is this is the it's going to be 4 of them, and one of them has 3, and the other 3 of them have 4 cutouts. And so you think, well, what do I do to make a new configuration that includes those things? And the first, exactly. Yeah. And so this is where it gets tricky because unless you've come up with all of the features that you're going to come up with for this particular thing that you're going to pattern or change the configuration for, it can get really tricky if you this other thing too. So I need to make sure all of the configurations get this thing. It's a very deep hole to fall into if you do, and I just recommend being mostly done with your design before you decide to start making new configurations of the design. And it's a hole I fell into, and I realized what I did wrong. And I just want to mention, don't repeat my mistake. I think anybody that's really getting started in this and tries to make those mistakes too. But okay, so first of all, let's just do a quick rewind of what this part is. So you start out with a boss extrude of a circle.
You put
I
a
do a
mate
cut.
reference in. The first thing you did was put a mate reference in.
The mate reference is durable. It's just it's actually missing the axis, so it just lives at the top. That folder can't be at the bottom.
Oh,
but
so
let's just say
you didn't put it in at first.
No, it just lives there.
Okay, got
it. If you notice, I dragged this axis up,
Yep.
and now when I highlight this, it actually includes the axis.
Yeah, love it.
So, okay. So first step is boss extrude a disk, and this is where I talked about this with Tim last week. I don't do revolves unless it has features that can only be revolved. I think it's a better idea to extrude something that's flatter than it is round. All right, so the next thing is to do the first cutout, then the second cutout, and then these holes, and then filleting everything. And unfortunately, because of I have to fillet that separately. It
too small.
SolidWorks doesn't have it doesn't have a very good feature built in. I found out actually that Xdesign in 3D Experience does have a full round feature, but it's still a little buggy and it didn't work out right. So whatever. But
so you drew a little half circle and cut it out. Is that what happened there?
No, I drew a full circle.
Okay.
Oh, you mean for the fillet?
Yeah, to do that, because that was a cut extrude that you did there instead of a fillet, right?
Yeah, so if you see the sketch, I just took the thing and did a
cool
convert entities,
and then fillet on those two opposite sides though too, right?
Say again?
You can use a face fillet feature. I mean, it would still be a different fillet item in your tree, but you could do a different type of fillet. Do the same. Pretty sure.
A face fillet.
Yeah, between two faces. Anyway, don't let me distract you. We're looking at configurations. We can do fillets next week.
Okay, and then I added this M8 hole for the screw, and so these are the features that are going to be. And so then I did the pattern. So now this is the part, and now I need to make one that has 4. So it's actually pretty simple. I'm going to create a new configuration by right-clicking and saying Add Configuration. I'll just say 4 instead. Okay, so now I've selected the 4 configuration, and now in circular pattern, I edit the feature. And if you notice, I don't know how close you guys can screen, but now under all the things that I can attribute to configurations, there are places to select that. So I'm going to go to specify configurations, and now it gives me a little box that allows me to set which configurations this change applies to.
Oh, that's super cool.
So in this case, I do not want default. So it's only going to apply to the active configuration because, well, I mean, this list would be populated by however many configurations I've. So in this case, it only applies to this one. So we're going to say 4, and we're going to change this to 4. Now I can also do it by selecting just this configuration. That essentially does the same thing. So now I've got 4 here, and I press go. So now I've got 4 here, and now just for fun,
that's sweet.
Now I got 3. Yeah. So when I bring this into the main assembly, I can tell it to select which one it uses. But most importantly, and this is actually how I did the actual lifting fingers in the original file a long time ago. Since there's 38 channels and there's 5 different configurations, you can pattern it down the line and then just tell each pattern which configuration to use. So Fusion doesn't do that, unfortunately. You can't actually.
Wait a minute, so in the pattern, you can select individual elements in the pattern and change the configuration within the pattern.
Yeah, so I'll do a short example to show you what I meant.
Yeah, that's pretty good.
So let's just start a new assembly. We will not do this. Move this over here. this guy over here. Okay, so just for fun, we'll take this guy, we'll bring it over. We will mate it. So float.
But the closest thing you can do in Fusion is you derive in the disk and then do the different changes at 2 different parts or something.
Yeah, exactly. Okay, so I've now brought this in. I'm going to mate it now, so let's just for fun. I'm going to do the quick and dirty version because, frankly, I'm in a hurry. Front plane. Go. Plane, and we'll go. Oops. Okay, so here is our single instance. It's now fully defined, and it's now mated. So let's pattern it. So we're going to go in the direction of, usually I like to put an axis in this, but I guess I might be able to pick up this axis. Yes, I can. Okay, good. So I'm going to say just for 36 millimeters apart. We'll say there's 4 of them. And we're going to say it's this guy. Okay, perfect. Okay. So now we've got 4 versions here. Now I know the first one is going to be 3. I know this one's going to be 4, that's going to be 4, and that's going to be 4. So all I have to do now is go into my local pattern, click this, and now if you notice, this little window doesn't normally show this box at the top that's default. You see how it says default?
Oh, yeah.
I don't know if I drop down, those are my configurations.
Oh, sweet.
So I just select 4, boom. Now the second guy is going to have 4. And now do it again. Select this guy.
Good.
Select 4. Select this
that's
guy.
So awesome.
Select 4. Boom.
So
now.
Good. Sorry.
Go ahead. No, you're good.
I'm gonna say, so we could do this for like all the vibraphone plates.
Yeah, so that's the whole point of right.
I'm
so
sure there's places like with the registrators, and there's a bunch of other places where there are. And there's like in the muting system, there are some places where there's some levers that go up and down. So we can design basically all of those variants in the same part file, and then just use whatever version of that part file where it's needed.
Exactly, and so you can do something similar where you have like a vibraphone bar as a part, and there's just one. There's no A flat, bar, whatever. There's just one, and then you use your what do you call it, global variables and a bunch of math to determine what the shape of each particular note bar is, and so now you've got a vibraphone bar file with 30 something configurations of that, and each one ends up being a specific note. And then you take that and you pattern it across a plane, and then it ends up being like your vibraphone assembly. And then you just select which note goes where, and then you can tell it, okay, well, this particular scale is for song whatever, right? So now you just configure all of your bars in the configuration for that song, and then you save the assembly as a configuration. So now that assembly can be configured to song A, song B, song C.
Loadouts.
Yeah, so you don't have to, there's nothing to do except for to select existing configuration.
Yeah.
When you build, and so that's efficient, CAD modeling. But the other thing is, this is one way of doing this, but in reality, this is not how the assembly is going to be built. When I bring in the disks, they're actually going to be rhythm beater disk assemblies. And so, for example, I have the drum,
the other clamping components in there, right?
Right. Well, so there's the drumstick. Well, actually, it's not. What did I call it? It's the rhythm.
Yeah, you think you want to do those as configurations of this disk, or do another level of assembly?
Exactly. So I just showed you how you configure and pattern parts within an assembly, but this is a little too simple because I deleted a lot of stuff before this because I wanted to actually show this as a example, but unfortunately.
So I'm wondering if we're doing something like the vibraphone design, we could just design the way that one vibraphone plate is held and then pattern that, like the whole holder and the entire, like that entire setup just for one note can just be patterned along and configured.
Yeah. So essentially, configurations is really but you're right. You're on the right track.
Yeah. And with the drop together, so you have the drop and the note and the resonator all in one thing, and you just say like, okay, 38 of those, something like that.
Yeah. In a sick way, that sounds like fun.
I think it sounds great. I think if we do that, that would be freaking sweet.
Yeah.
Now, there are some drawbacks with patterns.
Okay.
Do tell.
For example, mostly related to like motion. So if you have a whole bunch of objects patterned and each one of them you want to grab a lever and pull it, they basically all move together as one. And so if that doesn't matter, if you're just trying to get it all together so it looks good, but if you do want to try and explore, like different motion channels, pulling different levers, moving things independent of each other, the pattern kind of acts as one thing.
Got it. So in the vibraphone, if you wanted to show the deflection of the vibraphone, independently, because they do move, we would, instead of doing a pattern, we would just insert the number of whatever 13 things, and we can still use the configuration though, right? We can still make a dynamic.
Oh, absolutely.
Yeah. That's actually a very good point, and yeah, he's right.
And another thing is you could use a pattern to put them in there, but then you could dissolve the pattern and then mate them. So you might use the pattern to get them all in place, but then dissolve the pattern and all the objects would stay there, and then you would apply mates to put them or to keep them where they belong, kind of thing.
Cool.
So, like for example, here dissolve pattern, and boom, now they're just in there. So that's what he meant.
Nice.
Yeah. But the only thing is now I've got to mate these. I think in this case it's probably going to be a pattern, but he's right about the motion thing, and
So now can you drive different options and configurations out of global variables? So like, let's say if we have some equations about how the vibraphone plates change, right? But you're not going to pick, a circular pattern. You're going to pick it's going to be like a length distance that's going to be in your variables. That works. You can, or does it like multiple variables and like you just change what dimension you use for, like, you see what I'm saying? It's going to be like a relation.
You're just talking about changing the pattern. Yeah, you could do that. Or
no. So like in this example that David just gave us, right? He made a new configuration, right? And he made a change to one feature, which was a circular pattern, right?
Yeah.
In the case of the vibraphones, you're probably going to be extruding a rectangle, right?
Right.
It's going to be a certain length, and you'll probably control that length in a sketch with the reference to a global variable.
Yeah, I know which
dimensions.
I know what you're getting at now.
Configuration, right?
I have the perfect example to show you because that's actually
good.
So that works perfectly in this drumstick tip assembly. So this is a commercial product I bring from MasterCar, which by the way shows up over here now and tells you how many of them there are to buy. Yeah. But anyway, so this spring I bought or downloaded from MasterCar.
The drumstick is also actually an off-the-shelf component. I don't know.
It is actually
I guess.
Modified, in-house modification.
Well, the spring's modified, so.
Well, you're absolutely right. Actually, if I could find, but if you look at what actually is on the machine right now, there's like 8 different brands and sizes of drumstick that he used. So, Like I really wouldn't worry about that. But
And McMaster Car doesn't carry drumsticks. Actually,
Yeah,
they
good
might.
point.
No.
You never know. I haven't looked.
They don't label them as drumsticks, perhaps.
okay, so let's create two. So
Everything
This-
is a drumstick.
yeah, exactly. So right now we only have one configuration of this tip. It is the 50 millimeter version, I believe, from here to here. And there's a 50 and a 42. So let's just add one. We'll call it the 42.
Can you spell it out as the 42? No, it's okay.
No, let's do it.
I'm joking.
Boom. It's a 42 millimeter.
The answer.
You got
Okay,
what you
so
wanted,
that's the
Tim.
answer.
Do you still want it?
Sorry, I missed that.
Okay. No, it's okay. So
No, that's good.
now we're going to do a. Oh wait, you know what? I just thought of something. I need to.
No, wait,
I
hold
need
on.
to.
You're just making it smaller, right?
Yeah. I realize I have to add a feature first because if I don't do that, then it won't propagate. So let's not do that. We will go here.
Can you just change
Could
the
you just
dimension in your
and
sketch
say
or
it's for
whatever?
all configurations?
You'll see. Just
Okay.
keep your pants on.
All right. I wasn't
Okay,
trying to
so
take
I'm-
them off, but it's okay.
Yeah, don't
Okay.
worry about it.
I'm making a 42 millimeter plane right there. Boom. Okay. So now I have a 42 millimeter plane set
Oh, I
right
see.
there.
I thought that. Okay, I understand now. I thought you would make it shorter, like in the other way.
It's okay. And I will. Let's say. In fact, I probably should. You know what? I don't even need to do it because all I got to do is select the plane and then it will
Wait,
show up. There it is.
Question about this. So you're going to make it shorter in the back, but then when you use it in your other part, you're going to have to like use the new plane that you made, the 42 millimeter plane, as the reference. Is that the plan?
Yes. Yes. So.
Okay.
Okay, so I'm gonna now make that new configuration again. 2 millimeter. Actually, sorry, the 42 millimeter. Boom. Okay. So now I'm gonna go in and in my equations, I'm gonna manage my equations. And now, if you notice, in my configuration, or sorry, in my equations, there's now a
hot
configuration.
damn, there it is. Yep, got it. Love it.
So I can change these global variables when I'm in, and actually I can also do this from here. Because cut plane is at 42. This configuration, okay, right?
Right.
But if I go back in, not show properties. I don't know what it just did. Okay, manage
That's
equations.
awesome.
Now I'm going to change it to 50, and I'm going to go and I'm going to select the configuration I want to change it to, and I'm going to go okay.
So
now-
you selected them all, I think. There.
I think you might be right. So let's just go back to the default. It's a yes. Okay, so my default configuration is at 50. If I go back to the 42, it is at still 50 because I did it wrong. Let's just go to that. And then enter.
You pay internet.
Okay, wait. Now you can just change it to 42 here. No, just leave it to this configuration.
I did. It didn't change it.
42
It's
here.
because you didn't
and then-
change it to 42. It still says 50.
So now change it to 42. Yeah. So this should be good now.
Boom.
Nice.
Okay,
Yay.
cool. So now if I go into my extension spring and I open the part, go to the right, take this guy to the left. Okay, so now I want to make this cut to be actually using this thing because I have it set to whatever, but I don't want it set to whatever. I want it to be set to reflect what the assembly says it should be. So in this case, now I'm going to make my I should have it in here. There it is. Plane 3 is my cut plane. I have it set to be 25 millimeters away. So this is going to get a little bit more complicated. The way that I set up this part isn't able to actually take advantage of that. I would definitely have to, because it'll just create a circular reference.
Can't you just edit the part in the assembly? Then you have access to that variable instead of doing it in a window.
Sort of. I could also change this. Tell you what, let's do this. Let's try it this way. I will do equals and then select this guy.
That's not going to let you do that. It might let you do that if you were opening it in assembly view, like, editing it in assembly.
Yeah, let's do that. Let's do that. That's a good point. That's why I keep you around.
Thank you, Paul.
Let's close you, don't save. Oh, come on. I just did that. Okay. What are we doing here? Okay.
Full screen it.
Yeah. Oh, wait, you're right. I don't want to do that. I want to edit the part. Okay. So now this equals that. Boom. So now I think are we at 50? We are at 50. So let's actually first let's stop the component. Rebuild. This might not work because of how I built in this particular case, but we're about to find out. So now we'll go in our equations, manage our equations. Actually, no, we won't do that.
This one spring thing is so complicated.
Boom. Did it change?
The plane did. Yep. It did.
Okay, but the spring is not smaller.
Well,
it
doesn't have the cut operation in there, but the plane did move. The plane.
It was the circuit. Yeah, it was the circular reference. The way that I built this, I created a plane from the center line. I'll open it again and I'll show you what I mean. So I created a plane 3 that's 25 millimeters away from the center. And then I created plane 4 that's 50 millimeters away from that. So I need to make, I know what I can do. Okay, tell you what, I just figured it out. I just figured this out. Let's now go back here. We'll edit this. We will make plane 3 be this divided by 2. That should do it. Okay. So now here we are in, which configuration are we in? In 50. So if I do this, it should change to 42 now.
Yep.
And
it came off the backside, but yeah, it did.
Yeah, it's still not 42 millimeters long.
It's because you did the divided by 2 and you didn't do it on the first plane.
What do you mean?
Isn't the first reference you did was still 42? I don't know. I'm not exactly sure what your logic is here, so maybe.
Oh, it didn't change this. It didn't update it. This should have been updated. It didn't update. Cut plane at drumstick tip assembly dot assembly divided by 2. This shouldn't say 25 now. It should say 21. There it goes. Now it changed.
Okay.
What happened to it? What is going on here? So plane 4 should definitely now be.
And you might have set these references up. Oh, I see what you did. You may have set all this up differently in the beginning, knowing that you were going to do it can do a configuration.
Yeah. I probably should have done this slightly differently, but
Hey, can I ask, Amos? Can I ask you a question? Does this the way that David is doing this? Does this and specifically the way that he's not making the configuration until he is adding the configuration kind of parameters, the things that are changed in the does that smell right to you? Does that jive with the way you understand this? He unmuted himself, so now he's still there.
Oh, look at that! I lost my global variable. The problem. This one never saved for some reason.
Maybe because I guess you closed it at some point. Maybe, who knows? Okay.
So,
Amos, jump in whenever you.
Can you?
Yeah.
Can you hear me?
You can.
Okay, good. I'm sorry. I had to leave. I'm in my car now, but I can hear you. I just can't see what you're doing.
Oh, okay. Well, then you're useless.
Ooh, this is looking good. Looking promising.
yeah, I think I just fixed it. So we're in 42 now. So I'm going to change the configuration to 50, and the plane moved. But I think I have to reset.
It doesn't cut.
Wow. Okay, this is an issue. Something I have to. So, okay, there's another way of doing this, and that is to make two of the spring. And I think that's probably what I'm going to do right now. If you guys want to wait a second.
I have a question. If you create the split command in the assembly, can you do that? Is that possible?
Yes, actually, I probably could do that. Yeah. Actually, because that is an assembly feature. I can do... Actually, no, the split is probably not a feature for assemblies.
Lame.
So, to be honest, this is actually not the first time I've updating configurations don't seem to be instant. It's kind of bizarre. But let's do this. I'm going to open this part.
Seth the cat on the comments is asking what's this for. This is part of the rhythm beaters, the little hi-hat underneath on the crankshaft of the MMX that is doing the consistent drum beats. These are the drum stick tips that pop out of that actually hit the rhythm hi-hat.
Right. So I'm going to go back to making this a 50 millimeter long spring. And I'm going to make that the default length. So now this should be now 50. I believe it is anyway. Okay. So let's create a new configuration. We'll call it
configuration.
Are you making use of the Control Q, the rebuild?
I use the. I've always. Wait a minute. What do you mean Control Q? Is that assembly rebuild?
So if you use the little button for rebuild, it only rebuilds like back to the latest feature. But if you do Control Q, it's a full rebuild. And I habitually have my fingers over that because anytime you're changing global variables or stuff like that, Control Q will rebuild the entire design from the ground up, and it's gets the job done.
Huh.
Okay.
Thank you. We're seeing some things rebuild and some things not.
Yeah, there's just some things in SolidWorks that don't rebuild instantly, and there's actually some settings for that where you can intentionally not rebuild things because they would take time. But in assemblies like this, it's not very big. I always hit Control Q. If anything acts funny, hit Control Q.
To be fair, it's not something that I knew. I appreciate that, Amos.
You're welcome.
Okay, so now I've made
in Max, isn't Control Q quit?
Actually, it's Command Q.
Oh.
Yeah. But okay, so I've now made a global variable called length, and plane 3 and plane 4 take advantage of that. So I'm going to change plane 3 to have for its offset to be, instead of that outside one, I'm going to make it length divided by 2 on this guy.
This variable is in this part?
Yes. And I'm going to make this one, oop, going to make this one equal length. Okay. Okay, so now Control Q. I'm going to get used to doing that. Okay, so we are in the 50 millimeter configuration. Now, if I change to 42, it should get shorter. And it did.
Nice.
Okay, good. Okay. Boom. Okay. So now I am going to just save this. I probably don't have to do this because it's going to do. I just kind of get used to doing this as I do this.
I think in the next
Okay.
version, we need to just turn parts, like out of Delrin for these drum tips, and then just make the shaft the right size so that it has the right flexure that you need.
Yeah.
Just flip it.
Okay. So now we have.
Delrin drumsticks aren't going to sound the same. You got to use the wood one.
All right. So now we still have 2 configurations, but the difference now is that we can go in just like I did before and select which configuration that we change this to. It gets a little bit. It's like a sub configuration, but not really. So in this case, now you see this is a little bit more complicated. Now I have the configuration of the part, but also which configuration that even applies to in the first place. So it's So 40. Wait, which one are we on now? We're in the 42 millimeter display state. So we need to make sure that this is selected to be 42, and it's only for this configuration. And now enter. Boom. Now we have a short drumstick.
Nice.
So if I change to 50, you should see that now it's longer, but I want to make sure that we also select that. So now this one is this guy, this longer configuration, and now we're saving it to this configuration. And so now, boom. So now every time we change this configuration, it's longer and shorter. Boom.
Nice.
So now when I populate this into, when I populate this into here, actually it doesn't even go into this. It goes into the module, which I haven't shown you yet. I guess I could open that. When I open the module, I've actually already made it, so that's good. Okay, so this is the module it fits into, and this guy is going to.
And this thing itself has configurations as well, so that you can pick the sub configurations.
Yeah. So now, if you go to here, actually, there shouldn't be. I could have a long one, and frankly, so I haven't added it yet. I deleted all that stuff before this, so I could show you guys how that works. But essentially,
but that's the plan, right? You're going to have a configuration in here to make a long one and a short one.
Tell you what, let's do it right now. Let's add a configuration. We'll make it the. Okay, so now there's the default configuration, which I believe is probably gonna.
Do you have to do it that way, or in the assembly view, could you just pick the subcomponent of the module and pick your configuration? I guess you couldn't, because it would change it for all of them, right?
Yeah. So right. Okay. So sorry, I actually was not listening to you when you said that. Can you repeat what you asked?
Well, no, I mean, so let's say if you didn't make 2 configurations of this part, right, and you had these modules populated throughout the assembly, would you be able to change the configuration without it populating to the other modules, which themselves don't necessarily have to change? Would all the modules update if you change the length configuration within that part?
No, only when it like in this case, if you notice, there's only one drumstick tip assembly.
Yep.
But if there were 5 of these, then it would only apply to this particular drumstick tip assembly.
Take this subassembly and put it back into the larger rhythm beaters, and you still have granular control of your length.
Yeah. So let's just say for shits and giggles, we
You would have to have configurations of this subassembly.
Okay.
Yeah, you could do that too.
That's the question I'm asking is, would you have to have configurations of the subcomponent? And Amos is saying, yeah. Which is what you want to do. I was just wondering if it was a necessary step.
Yeah, so that was the trouble I ran into when I because I had painted myself into that corner where I ended up not making subassemblies and then configurations of those subassemblies, and I ended up doing exactly what you asked, and it caused that problem. So this is why I'm trying to fix it, which is why you go into the base parts, and making them configurations based on their own particular different lengths, and then you can go and configure what they live in, and then tell that which version of it you want, and then you pattern that thing. So yeah, thank you, Amos. Appreciate that. Okay, so now we're in the drumstick tip assembly / rhythm beater module, and so we've created a configuration for a short one and a long one, and so now all I got to do is choose which one gets which one. So drumstick tip assembly, we're going to, because we are in the short version, we're going to pick the 42, and it's only in this configuration, and then check, and now it should give us a 42, which I think it did. And so if we check the longer version, we pick this guy, we say the default configuration and only in this configuration. And did it give me, I don't think it changed, did it? Why did that not change? Huh. This is bizarre.
I don't know that you selected it.
Maybe I need to press Control Q. Let's do it.
Worth a try.
No, didn't do anything. So, okay, this is our drumstick tip. The default configuration of the drumstick tip is 50 millimeters. We know that. So if we go back to the assembly that contains it, and we select the default configuration of it, and this configuration, okay, maybe that is 50 and I just don't notice it. Just switch to the short one.
How is your mate set up?
That's it. That's it. You asked that right as I saw the. Yeah. Okay. I realize now what I forgot to do.
Or something else instead of the
yeah. So I'm mating it to this plane, and this plane is set up for 105 millimeters from the center, and that also has to change.
Yep.
So let's go back to our default configuration. Okay, we're in our default configuration. That's fine. Let's now go
I think we get it. I do have someone coming to visit me in about 10 minutes, so we don't need to fix that. But let's recap it, right? Which is that if we're going to make reusable components, right? Let's say with this drum tip, then we can do that with configurations, and then if each of those configurations, like let's say like you could do like a custom fastener library right this way, right? You have an N6 bolt with different lengths, right? I know they have a smart fastener library which we'll use, but you would need a configuration of each basically granular part that you want to be able to select different versions of.
Right.
And you would just make sure that when those things change, you have the mates set up so that it works. And then, yeah, I can see us using this all over the place. I mean, the white versus black knobs on the trigger releases, the funnels for the drums are different sizes. That could be a configuration. How big the tines are. I mean, we can do all sorts of fun stuff. I really think that's cool.
Yeah. So I realized. There we go. Just to give you a quick visual to close out.
Can I chime in real quick here?
Please do.
Please.
The 3D Experience platform handles configurations a little bit differently than just how SolidWorks handles them. So it does make a separate, essentially a separate part file on the platform for every configuration.
Yeah, we noticed.
Yeah.
So
Yeah.
that is kind of one of the things to think about. It probably doesn't hurt anything. It's just something to be aware of that's different from standard SolidWorks functionality.
Well, and that's the thing where they have a cat when you can open a file that says CAD family, right? You're opening up the
the CAD family is basically the master file,
right.
And then each configuration is the I forget what they call it, the product.
Right.
Physical product.
Physical product. That's right.
Yeah, it does make the looking at it through your 3D drive and seeing all of those duplicate things a real. It makes 3D.
Yeah.
It makes it hard to look at.
And there is a way to help that, which is to turn on a filter, which only shows one or the other.
Right.
So you turn it on so it only shows physical products or CAD family, depending on what your preference is.
Right. Sweet. So now, Amos, you can't see it, but David has now made a configuration so that you can see normal and you can see just the normal version and the I just walked out of a cold pool version.
Cool.
Yeah. So yeah, it wasn't too hard, and so I can even bring this in. I mean, I don't know how much time you got left, but I could bring this into the disk and then pattern. Okay. So what do I already have open still? I believe assembly 1 is the one we're working on. Okay. So just for fun, I'm actually going to delete this pattern because it's not really needed anymore. Okay. So the rhythm beater disk is in, and I'm going to bring the where'd it go? The rhythm beater module in. And we're going to put this in here. So
now you can drag those things. I mean,
and you see how it just say again?
You have
how did it what?
Mate references there.
That's the mate references made it just go poof instantly in the right spot.
Oh, that was nice.
Yeah, and so now
I can. When you drag another one, will it go into the same spot?
It will. Yeah.
Okay.
Yeah. So now I'm gonna
pattern it anyway, though, right? So you're okay.
Yeah.
Yeah.
He set that up for a nice
your
demo.
Number of patterns isn't a global variable, right? Which you'd have to do in order to make them both drive off of one thing.
Well, so I can't make them drive off.
Now.
Say again?
I was going to say just do a configuration with the pattern number and all that kind of stuff.
Oh, just
and I will.
Yeah, it's okay.
So first I'm going to pick this guy as the corner. Now, I didn't put an axis in because, frankly, I just made this from scratch. I could have put an axis in. In fact, you know what? I am going to put an axis in because that's usually what I like to go by. I think it's far better than using a physical face.
But you have an axis. If you just show you'll have a hidden axis in there.
Yeah, show the hidden axis.
No, it's too late.
Oh, right. Yeah, you're right. I could have done that. All right. It's too late.
The lazy man's axis.
Anyway, so now that my axis is there, because frankly, this is a philosophical question, and for me, I prefer to mate off of reference geometry, not off of part geometry. Because if you do it off of part geometry and something changes, and now you no longer have that part, your model's going to blow up. But if you do it off of like durable things like reference geometry, you're not going to lose that. But okay, so I could also bring in the through, but for the purposes of this, let's just add the module. So we will do our not linear, sorry, circular. Direction is going to be our axis. We're going to do 3 of them. Now this number doesn't really matter. It will come in later. But the component will be this guy. And boom. So now that's in there. And if we select it, there should be a 3 that shows up. And there it is. You see the 3?
Yep.
Boom. So you have to double click it or else it'll just give you that little box. But I want to... Boom. Okay. Now we're going to go equals. And let's call it modules. Okay. So now if we go in our equations, we already created one called modules. So that's good. So now we can actually, we can technically go to our rhythm beater disk 1 and we can edit this.
You must save and hit Control Q.
That's okay. I'm going to throw this away as soon as.
So wasted.
But I will press Control Q. Okay. So now that we're editing the rhythm beater disk, we can go into our circular pattern, grab that same 3, and tell it to equal this.
Mike, come on over.
Come on. Equals that. Boom. So now when I change that.
Another 15 minutes. No, 4:30. We're here.
So now I can go in and say equations. Actually, let's finish editing the component. So now we can go in our equations.
Why don't we just do it Monday then? Sorry, David.
That's okay. Go 4. Now this should populate. Unfortunately, it did not populate that. But I guess if we press Control Q. So pressing Control Q fixed it. So now you see I've tied both the cutout and the circular pattern for the modules. So now I can go in and say assembly 1 configurations, we will add one. Now let's just say 3. Boom.
I gotta step off, guys.
Thanks,
We'll see
Amos.
you later.
Appreciate it, man.
Take
Thanks,
care.
Ben.
Thanks for coming.
Okay, so for 3, we're going to make it this configuration and go okay. Okay, now Control Q. Whoop, not A. Control Q. Uh-oh. What are we doing? Be funny if SolidWorks quits on me now. Uh-oh.
No. Right after it has to wait
And
until the
on
very
that
end.
bombshell, we shall end it.
Yeah, exactly.
Okay.
I hope not.
There's the default 4. Now 3.
Okay. Wait, hit
Why did
save,
it not
hit
update?
save.
I'm going to go back to equations here. Let's see what
Hit
happens.
save. You gotta save.
Why do I have to save?
I mean, I guess you don't have to, but
When Ananda gets nervous, it's like hit Control S. Talking to a pretty girl, Control S. I might crash and burn, Control S.
well, at least when you're dealing with SolidWorks, you gotta Control S all the time. Although the annoying thing now is that it has to upload it.
Yeah,
it's
it
slow.
gets annoying. Ooh. And it didn't. Sometimes it doesn't reserve the top level. I don't know why it does that.
That
Okay.
is weird.
Okay, so I have to go back to my rhythm. Figure out. Did not do the cutout.
Yeah, you did you not assemble? Did you not pattern link this one to that same global variable? The configuration on the disk. I don't think you.
Oh, look at that! I only made it go for configuration. I need to make it for all configurations. That's why. So it didn't repopulate because I didn't tell it to.
Imagine that.
There it goes. Okay,
Hey.
so now Yeah, so now if I should be able to... Fuck. Pardon my French.
Yeah, man, just doing it like for this configuration definitely takes a lot of time having to go back and forth and figure that out.
Well, again, you wouldn't be having this problem if we designed it with configurations in mind, right? You would order your stuff differently, right? We're watching David fix something that wasn't optimized this way. But
yeah, so the other way is creating a config and then going into my top level assembly and saying, okay, this is an assembly, or this is a configuration of 4, so make 4 of those. This is a configuration of 3, so select the 3. I was trying to make it automatic, and it wasn't working.
I'm with you.
I think it would be better if it could be automatic. It'd be awesome. But it seems maybe if I do Control Q now.
How you could, right?
So hold on, yeah, wait.
This particular model is a little less interesting, but it's obvious that you can.
Mm-hmm.
So wait, the problem is that it's not switching the configuration of the beater disk when you switch the configurations of the full assembly.
Yeah. So ultimately,
but it's doing it on the spring though, so that's interesting.
Yeah. So ultimately, for the marble machine, there are going to be 4. There's the triplet, which uses 3 and long beaters. There's going to be the quarter note, which uses 4 and the short beaters. There's going to be the offbeat, which uses 4 cutouts, but 1 short beater, and it's in the 180-degree position. Mm-hmm. And then there's the whole note, which uses 4 cutouts, a long beater in the normal 270-degree position, and the second one I meant 90-degree position. So, so it's like there's only going to be 4. There's no infinite variety. There's just going to be 4.
Right.
Essentially, this assembly 1 configuration is really just going to have triplet, quarter, offbeat, whole, and it's not going to be this like infinite thing we can pick from. So, off camera, this will take me another 10 minutes to put back together the correct way. But then when I do, all I have to do is bring this into the main rhythm machine assembly and then pattern it times 4 and then tell each instance which version of that it is. Yep. And this is all stuff I kind of screwed up a couple days ago and then deleted. So you're seeing me rebuild it in real time before I had a chance to prepare.
Got it.
But anyway,
it's good.
Yeah, but anyway,
this is amazing. I mean,
yeah,
it almost like kind of makes me think differently about. I mean, I'm just kind of playing this like there's so many different places where you could use you think about your assembly differently structurally when you know that you can do configurations.
Yeah, the whole machine is going to be full of a lot of that. Where I mean, you can even do fasteners like that. Yep. In fact, if you look into smart fasteners, that's the way that they build it. They have this.
It makes sense.
They have this weird sketch at the beginning. Usually, it contains all of the data, which is kind of annoying. It's not really how you should build it, but because it's an internal SolidWorks thing, and that's just how SolidWorks pulls the data. That's just how they work. But to change from a 50 millimeter fastener to a 100 millimeter fastener, all they do is change 1 data point, and then you have a totally new thing. So it's kind of neat.
So if all you're doing is changing a length like that, you don't really need a configuration. You just change the length of that feature in the configuration.
Right.
I mean, you don't need like a separate whole part that you're pulling in.
Well, yeah, but if you're using multiples of that same part in another assembly, right? Like if you have 15 M3 bolts, some might be 15 millimeters long. You could just use a different configuration of the same part.
Yeah,
sounds like a philosophical question to me. Yeah.
Yeah. So, but in the case of this particular model, I'm going to use as many McMaster parts as I possibly can where they go, and instead of creating a spring, which is actually pretty easy to do, I decided to bring it in from McMaster Car and then pattern it. But in the case of just random screws everywhere, those are going to be in a special kind of place. They're going to live up here in a folder. You don't even see it because it's for selection sets. And when you have a selection set, you can just suppress all of them all at once, so that things like fasteners should be suppressed by default. And if you really want to see them, be prepared to watch your computer chooch for about 10 minutes. But when it does, great, you have your fasteners. And that's kind of how we should do it with the fasteners. But if we do it with McMaster Car Integrate, the only thing is they have to be modified first, because sort of like I modified these screws to be short. You might have seen these are a pull spring that has a hook on the end, and I had to get rid of all of that.
Yeah.
But the neat thing is McMaster Car still sees it as that part number, so it knows that you need to buy it, right? And now you notice how there's 4 in there. So it's a pretty smart feature. And it's the same deal with screws. We should include them, but they have to be modified to eliminate all the thread first, because there's no way you could possibly do that practically.
Super cool.
But it's super simple to do. Once you open it, it's not hard. Like, for example, actually, I'll show you an example of that, because I have one.
We're gonna need to taper this thing off now.
Okay.
Yeah, we need to go. I have someone who should have shown up by now already. Okay.
All I did was I suppressed the helix, and by suppressing the helix, it suppressed the cut sweep and the rest of the stuff it doesn't need.
Oh, it suppressed all the child features.
Yeah,
that's pretty good.
So you don't have to go in there and do a bunch of modifications.
Yeah, that's nice.
Yeah,
cool.
And then I just added the hole.
Well, Andre and David, thanks for hanging out. Thanks for being flexible on the start time. I think this was really cool. I learned a lot. I'm going to, on the Music Box project, I'm going to have a bunch of stuff to do with kind of the torque engineering. I'm going to pick a motor, and I'll have something a little bit more polished to show. And we'll figure out kind of what's next on the MMX again for next week too.
Sounds good.
All right, guys.
Yeah, sounds
thanks for hanging out. We'll do it again next week.
Yeah, see you later.
All right. Cheers, guys.